First of all, welcome everybody. Thank you for joining our third webinar in TIMEPAC Academy. The topic of today's webinar is analysis and visualization of EPC data and development of innovative energy services. As you know, planned time for this webinar is 2 o'clock, and we will have some time at the end to discuss and to answer all your questions. For this webinar, we prepared this agenda. First, we will have a welcome word from our director, Dražan Jakšić. After that, Benjamin will present the key elements of BIM and for analysis and visualization of EPC data. Ružica will talk about dynamic simulations of energy demand. Franz will discuss about comparison of modeled and real consumption data. And Suzanne will present the concept of renovation password. After that, we will go a little bit deeper in energy efficiency measures and identification of cost-optimal investments and creation of renovation scenarios. How to make an EPC a dynamic tool for verification of energy savings is something that I present as your host today. And for the end, as a cherry on the top, Boris will present reporting, monitoring, and verification of energy savings. As I mentioned before, we will leave some time for discussion and the closing remarks. And before each presentation, I will briefly present the presenter for this session. So I can see that people still entering the lobby. Nevertheless, we will start with our program. And what we are going to tackle here is basic questions like analysis and visualization of EPC data and its utilization in development of innovative energy services. And the main objective is to equip you participants with the knowledge and skills necessary to harness EPC data for the preparation of deep energy renovation projects. This is all these tasks are basically, and all these efforts that we trying to implement in the project are to help energy renovation projects to be better, to be more precise, and to be more, let's say, more feasible. We have 7 sessions planned and speakers from Austria, Croatia, Cyprus, Italy, Slovenia, and Spain. So to be on the track, I call my director Dražan Jakšić to give us a few opening words for this webinar. I will stop sharing so we can continue with our program. Okay, Dražan, the floor is yours.
Yeah, thank you, Ilya. Good morning, everyone. I hope you can hear me well. I'm pleased to be today with you. I see you have a very dense program today and very interesting one. I don't want to take lots of your time for this webinar, but Ilya asked me just to give a brief welcome note and an introduction of Energy Institute Hrvoje Požar. He is a partner in this program. I'm the director of the Energy Institute now for 4 years since I became director. Energy Institute is an institution owned by the Republic of Croatia. It implements scientific research in energy. It provides also support to public authorities, but also have economic activities for different companies and provides also consulting services in all fields of energy. Currently, we have about exactly 84 employees, and our annual income is about 5 million euros. And we cover practically all fields of energy, from energy balances, energy statistics, energy markets, of course, renewables energies. We deal with energy mobility. One of our major areas of activities is energy and climate planning, also power grid planning and development of grids, both in power and in gas, and energy regulations and economics, and of course energy efficiency, which is very strong in the institute, and in that area, of course, energy performance of buildings and their assessment. I would like to stress that we started with these activities, for example, with energy audits, and even before it was a legal obligation. And we also, with the education of energy auditors, we started in 2009. So we have already 15 years of experience in providing education activities in this area. So currently we also participate in 11 projects dealing with energy certifications, energy audits, and generally in energy performance of buildings. So we have a huge experience, a very good team, great experts in our institute, and I think that we can also bring a lot of knowledge into this project, which I'm very happy that we are involved in it. So that's it for this short introduction, and I wish you a very fruitful webinar today and successful project in general. Thank you very much.
Thank you, Dražan, very much for this introduction and introduction of our institute. So we can move on with our program. Maybe it would be good to for all presenters that are not presenting to turn off the camera so that we don't have any problems regarding connections. I will start first. Our first speaker is Benjamin Gonzalez. He is an industrial engineer who graduated from Polytechnic University of Valencia and holds an MBA from UNID. He currently serves as the Corporate Development Director at the SIPE with a career spanning since 2003. He has played a key role in the development of SIPE's thermal study suite, overseeing the calculating of thermal loads in HV system, as well as the compliance with the thermal regulations in Spain, France, Portugal, and Morocco. He has also been involved in projects related to the acoustic and energy calculation of building using Energy Plus. In recent years, he has been actively promoting research project initiatives, particularly in the integration of the thermal models with the BIM workflow. Benjamin, the floor is yours.
Thank you, Ilya. Your pronunciation, congratulations for the pronunciation of my name, because it's not easy, I know, for you.
Thank you. I was thinking about is it Benjamin or Benjamin, but I think Benjamin is correct.
It doesn't matter. It doesn't matter. It's okay. It's okay. So thank you very much to be invited for this first session. I guess it will be my presentation. This session, the session 1, is the key elements of the BIM key elements for analysis and visualization of energy performance certification data. This is the title of my presentation. And well, I'm going to talk about the following points, the elements, the key elements that we need for. We are talking about EPCs, energy performance certificates, the data, and I'm going to talk about BIM, building information modeling. What is the different elements, the different points, of the important points, the key elements that we need? The first one, I'm going to talk about the common data environment, the CDE. This is the cloud where the place where the data will be, and this is very important, and we will talk for a few minutes. The second part is the BIM workflow. It's important to know that if you are going with the different workflow, how to use the BIM technology to connect this analysis, this data, and these EPCs. And I'm going to continue with the different tools for 3D architectural modeling, tools for design and analysis from an energy and the different point of view. I will focus on I will focus on energy simulation, of course, and the next one will be the EPC and the improvements, the measures tools that we can use. And finally, I will talk about the different parts, the different outcomes that we can have the platforms, because we have some data and how we can manage this data. And finally, the conclusions for these presentations. Well, the first one is, let's get started. The first one is the common data environment. When we are talking about a common data environment, we are talking how to manage the different information from the different stakeholders that we have in a project and in construction, in a building in general point of view. For example, from architecture point of view, the 3D models, MEP, mechanical, electrical, plumbing, structures, management, for example, the bill of quantities, maybe the CO2 of the environment, reports, and so on. All of this is stakeholders can work together and can generate the information. And for that, one key ingredient or element is the common data environment. This common data environment could be focused on one tool or with an open BIM approach. The open BIM approach, just in a few words to define that, is just to generate a project delivering standards, open BIM standards like IFC or JSON or different kinds of standards files, like I said before, and any specialist can provide his reports and his outcomes. In this case, all delivered into the common data environment. This is one piece that is important. The second part is, if we are working with this common data environment, it could be, for example, with no proprietary format that I said before, and the maintenance. If we achieve this goal, we will get the important thing that in the future we will be able to take all this information. The workflow this is the common data environment is the first one. The second one is the workflow. We can use different clouds, different common data environments, but always used to be the same. We have a 3D model. This 3D model can have with plugins or without plugins, or maybe we can take this standard, this IFC, and with this IFC, what we can do is to generate this IFC can get in the cloud, and every specialist can generate the different reports. In the APC, in this case, is the energy simulation and the different measures, and we can delivering the different bill of quantities, the specifications, even drawings, 3D models, that is part of the BIM export is important, and check reports, and of course the EPC report as well. All of them can be in the cloud, and they will be able to consult and to work with this data in the future. If we continue, one of the workflows that we can do is this 3D model. I mean, we're focusing now in the EPC and the energy simulation. We can take this 3D model, and via IFC, we can see here the IFC, we can generate via this kind of tools. This is a free tool, actually, OpenBIM Analytical Model, and we can connect with different tools like CPTM or other tools. Another option is the same way, but maybe if we are in the EPC not for new buildings, for another kind of buildings or for renovation, we can use this kind of tools, but always we can have drawings. We can have some drawings, DXF, or even a GPG, a picture, and a scanner of the building, and we can take the building and generate the same simulations. This is another part via taking the drawings and generating and simplify or a customized 3D model for energy analysis. This is another free tool, ILC Builder. You can do the same. At the end, we have the workflow. This is kind of the workflow, and we can use different tools. Different tools could be 3D architectural modeling tools, for example, Autodesk Revit, ArchiCAD, Allplan, or a free tool is SIPE Architecture. This is the 3D architecture model. This is another key point. We are talking about BIM, or we have these 3D models. For example, another simplified model is with IFC Builder, as I said before. And well, if we continue with, this is what I said, this is the different tools that we can use for the key ingredients. We say common data environment, workflow, communicating with the common data environment and for every stakeholder, 3D architectural modeling tools like that. This is simplified models. And well, one of the important things for the EPC, in order to generate EPC, for example, are the thermal bridges. The thermal bridges, you need to analyze these thermal bridges, these kind of tools. You can get it, the different geometry, in order to analyze afterwards with your energy simulation tool, the thermal bridge that you have in the building, or the different thermal bridges that you have in your building. Well, this is a point. I'm very quick because I have just 10 and 12 minutes, but summarizing, we have common data environment, we have the workflow, we have an architectural model, and now we have the design and analysis tools. With this 3D model, you can provide the input, the 3D model, in order to analyze and to use not only for the EPC, it's for a design for thermal loads, for energy simulation, lighting, acoustic, or maybe structures, for all the things that you need for your EPC. In this case, the EPC is more focused on energy, but remember that in the future you will have for more things, for example, for environment values like CO2 or more parameters. Well, this is a thing that we can take from the 3D model, and afterwards we can take a customized tool for every country. In this case, the EPC that we can take, we have many tools in Italy, in Spain, in Slovenia, in Austria, the country that we are talking, Croatia, the tools that we have, and this is an specialized tools or customized tools for every country. The EPC is not for a European scale, it's for country scale. And in this case, you can use some tools. In the case of SIPE, we have in Italy, we have in Spain, of course, we have in France, in Portugal, even in Morocco, like Ilya said. But in this case, the EPC, you can take all this information from the common data environment and to provide the EPC tool in order to generate the EPC report. And one of the things that we think is important in this webinar, we will talk about it, is the improvements, the different measures, the different options that we will have in order to take the best decision for renovating the building. Well, this is the next part, and the outcomes. We have used all the information in order to analyze, to take decisions, and after that we need to take all this information from this, in the beginning, common data environment. We can use again the common data environment. In this case, it's BIM server.center, but this is one of them. And the thing is, what is the information that we can take? What is the outcomes that we can take? We have the platform. This is another key point. And in this platform, one of the things that we can take is, for example, we can see here the XML. This is the file that we need for the EPC, or maybe the different reports, the reports with certification, the PDF. The PDF is a good standard for reports, or maybe an IFC, or even a GLTF is a 3D model, something like that. What we have is we can take this 3D model, and we can be sure that the EPC is correct, and we can show what is the different measures, and to check that all the calculation, all the analysis, all the measure are in the best way, and they are correct, and they are it's not a problem for the future. And with this information, the good thing with this information, you can take this information now, and in the future, it could be used by an input for future renovations that we can do in the building. So, of course, the new technologies outcomes, not now it's possible, but I guess in the future we will be able, and now it's possible to do it with virtual reality, augmented reality, or to have your EPC in your phone. Now it's possible with this kind of platforms. And at the end, for public bodies, or even for big companies, or maybe SME companies as well, another key part of the BIM elements is to have a connection between the common data environment with the rest of the databases, platform, and so on. And it means that every common data environment needs a REST API web service in order to connect all this information with the databases for public bodies, for construction companies, or every stakeholder who need it. This is just an example. And as a conclusions, working with BIM workflow is more effective. Indeed, it's possible to do it. Another part is if you choose some tools, is no need for high investment. It's possible because there are some free tools in the market. Using the common data environment as an information base is possible as well. It's possible to take this information as the way that you can take all the information. Tools can communicate more effectively via IBC, and one of the goals of TIMEPAC project is to show how it works. And all stakeholders can get valuable information from this workflow, and this is this BIM technology. Okay, so from my side, thank you very much. Ilya, all yours.
Benjamin, thank you very much. Thank you for being on time. We will proceed with our program, and I will present my dear colleague Ružica Jurjević. She is a mechanical engineer, master's graduated, now in pursuing her PhD since 2022 on the Faculty of Mechanical Engineering and Naval Architecture in Zagreb. Her research focuses on developing a method for assessing demand response potential in the building sector. Currently, and hopefully in the future, she is employed and will be employed in Energy Institute Hrvoje Požar, because we like her very much and he's a really good colleague. In the Department of Energy Efficiency, her projects primarily involve implementing and quantifying energy efficiency measures in individual buildings, all building clusters. And to achieve this, she utilized dynamic energy simulation tools such as Design Builder, Energy Plus. Additionally, she has been actively involved in organizing various educational events, including training sessions like this one, for energy auditors in Croatia and abroad. One of her interests is also in nearly zero energy building, and she is a part of our team where we are working on refurbishment on our building. So without any other doing, Ružica, the floor is yours.
Thank you, Ilya. Just a second. Do you see my presentation?
Yeah, we do.
Okay. Hello, everyone. My name is Ružica Jurjević. Today, I will present you a dynamic simulation of energy consumption. Here is the content of this presentation. First, I will show you in general about dynamic energy building modeling. Then I will state the advantages and the disadvantages of using them. Also, an overview of software tools for conducting dynamic simulations will be presented. And finally, it will be shown for what purpose dynamic simulations can be used on the example of the building of Energy Institute Hrvoje Požar. So let's start. What is dynamic energy building modeling? It's a complex process of creating computer models of energy systems for their analysis over a specific time period with a defined time step. And this time period indicates the time for which we conduct simulations, such as 1 year, half year, heating season, etc. While time step is the time in which we conduct simulations. Thus, time step can be monthly, daily, hourly, and so on. For that purpose, we usually utilize commercially available or open source software tools. And the results of dynamic energy simulations are data on energy consumptions, CO2 emissions, and overall costs. And all these data enable engineers to conduct feasibility studies, for example, choose the optimal solutions for new building or building renovations. Here is advantages and disadvantages of using dynamic energy simulations. Some of advantages are that dynamic energy simulations enable more precise output results than simplified calculation methods. Provide a detailed insight into achieving thermal comfort and air quality, provide ability to observe building characteristics in shorter time steps, for example, hourly, and provide automation capability in the model creation process. But there are also some disadvantages, which are much less. For example, dynamic energy simulations are complex processes, require a high level of expertise, demand high quality input data, but all these disadvantages are perhaps better called challenges, because high level of expertise and high quality input data are necessary for any analysis. Here is an overview of software tools for conducting dynamic energy simulation. Some of these tools are Energy Plus, which is widely used for building energy simulations and suitable for various building types. Here is also Thersys that offers a wide range of simulation capabilities for renewable energy systems. And additionally, there are OpenStudio, Design Builder, Modelica, EDA, VIP Energy. But for this short presentation, we singled out Energy Plus, because it was used in the example of Energy Institute Hrvoje Požar building that will be in next slide. Energy Plus is program for conducting a whole building energy simulation, modeling energy consumption for heating, cooling, ventilation, lighting, and domestic hot water preparation. This program is console-based, that reading input data and writing output data to text files. And it's important to say that this program has also detailed documentation that was available online. That is available online for those who want to learn or perfect its use. Here is example how dynamic simulation tools can be used. The building The building of Energy Institute Hrvoje Požar is currently being renovated, and dynamic energy simulations were used to find the optimal solutions. And in our case, dynamic energy simulations were performed in Energy Plus and Design Builder. For that purpose, four steps were conducted. First step was performing collecting and entering building data into an advanced software tool, in our case, Design Builder and Energy Plus. That data include construction data, technical data, occupancy data, operation schedules, and climate data. And the second step is performing dynamic energy simulations, where in our case are implemented a huge number of combinations of building deep energy renovations measures. And based on output data, it's necessary in next step perform technical and economic analysis, and based on these results choose optimal solutions for building deep energy renovations. Here is all combinations for deep energy renovation combinations for our buildings. We analyzed a total of 720 combinations. Different thicknesses of external wall insulations are analyzed, so from 10 to 20 centimeters, different insulation thicknesses of flat roof, 3 different windows. Here is heating energy sources, which include district heating, micro-cogeneration, water source heat pump, air source heat pump. That means 3 different fuels, district heating, natural gas, and electricity. For cooling energy sources, we analyzed the compression cooler, water source heat pump, and air source heat pump. For all these cooling energy sources, the fuel is electricity. We also analyzed the three different lighting systems and photovoltaic systems, which is always the same for all combination, because we will install that photovoltaic system on our roof. For each of combinations, primary energy and specific building life cycle costs were calculated, as is shown on this graph. It's important to note here that it was necessary to satisfy all regulation in Croatia, in our case, so all combinations marked with X don't meet a legal framework in Croatian. That combination exceed maximum primary energy value and so on, and the maximum required energy for heating. Such combinations are not considered, and only those marked with circle are observed. And the optimal solution is the one that has the minimum value of primary energy and the minimum value of specific building life cycle cost. In our case, the optimal solution is here. For our building, source of heating and cooling energy will be water source heat pump. LED lamps, primary energy is -6 kilowatt-hour per square meter. That means that in our building we will produce more energy than we will need. Specific building life cycle cost is about 425 euro per square meter. LED lamps are chosen as lighting system. External wall insulation thicknesses is 14 centimeters. Flat roof insulation thickness is 16 centimeters, and window value is 1.40. This is a very brief overview of dynamic energy simulations and how they can be used. So I understand that you maybe have a lot of questions. So if you have additional questions on this topic, feel free to contact me or text on chat. Thank you very much.
Thank you very much, Ružica. It was a really good presentation. And for the next session, I will present our colleague, Franz Bianco. He's an engineer who graduated in building engineering from Politecnico di Torino, currently a PhD student, Department of Energy, Galileo Ferraris. His research activity is part of the research program, International Environment and Energy of the Building, with a specific focus on dynamic energy simulations of building, model validation, as well as energy and economic optimization of new building projects and redevelopment. His work contributes to advancing the field of building physics and energy system through innovative research on energy efficient building design and optimization strategies. So, without further ado, Franz, the floor is yours.
Okay, thank you so much. I'm gonna share my screen. Can you see it?
We can see it. You can just put it on the slideshow.
Yes.
Yeah,
Yes.
great. Thank you very much.
Thank you. Thank you for the presentation. Okay, as said, I'm Franz Bianco Degerfeld, and now we will talk about the comparison of the model data and the real consumption data. How can we assess the energy behavior of a building? We have two main paths. The first one is to use detailed real measure data, but this data has high requirements in the term of quite precise sensor and also in terms of expertise, because in order to manage to use this sensor, a high skill level is required. But of course, this data has a high accuracy since these are real data and of course are quite able to reproduce the real behavior of a building. But of course, they also have a low flexibility since they can only represent the current status, the current use of a building, and cannot simulate other situation of the building. On the other hand, we have the building energy models that has low requirements in terms of software and the expertise to use this software and to gather the required data, and also has a variable accuracy, which of course depends on the quality of the data, the quality of the methods used to assess the energy performance, but of course has a high flexibility since they can predict, they can assess various configuration of the building we are analyzing. Of course, we have these two things, but is a trade-off possible? Meaning, can we merge the qualities of these two things in order to have something that is both accurate and flexible? We can do that by actually mixing these two things. So if we start for a BEM, building energy model, and as we said, we have unreliable data, missing data, and human errors, through a calibration procedure, we can try and we should achieve a building energy model who does not have any more these issues. But what is a calibration? The calibration is the process of reducing the uncertainty of a model by comparing the predicted output of the model under a specific set of conditions to the actual measured data for the same set of conditions. The issue with the calibration is that right now there isn't a standardized procedure, something that we can and we should apply. So what we did in TIMEPAC is that we choose a calibration procedure, we analyzed it, and we applied it to different configuration, to different building. The procedure we used and the procedure I'm going to explain right now is mainly divided in three different group of phases. A first one, which is the preliminary activities, a second one, which is the core of the calibration, and the last one, which is mainly the evaluation of the results. So let's start from the beginning. Of course, we start analyzing the monitor data we already have. So in terms of both the type, meaning something like the energy consumption, the indoor temperature, and the temporal discretization of this data. So if we have seasonal data, monthly data, hourly data, or sub-hourly data. The second step is to analyze the data we have also for the building. So we need to gather all the data, the relevant data, to actually create the building energy model, meaning that we need to gather the data regarding the outdoor environment, the building fabric, the indoor environment, the technical building systems. And of course, between these data, there are some data that are mandatory in order to be able to both produce the building energy model, but also to be able to achieve and to perform a calibration procedure. And we can see those indicated in green. In case some of the data are not available, we continue with the third step, which is the derivation of all the data that are not mandatory, but are needed to create a building energy model. So some of these data can be derived from standards, but also from other databases, other sources, such as the national, international legislation, market analysis, and so on. Once we have all the data needed to create the base model, the building energy model, we can actually create it using this data. The fifth and last step of the preliminary phases is to choose the calibration scenario. And this calibration scenario should be derived from the data we have for the monitor data, but also from the relevant output for the simulation we're going to perform for the building energy model. Because of course, if we cannot achieve hourly data with our simulation, we will not be able to perform a calibration using hourly data since we don't have this data. In this case, we're going to analyze a specific scenario, the scenario 1, that use the energy consumption as a type of data and the monthly as a temporal discretization of the data. So let's go with the core of the calibration phases. At first, we take our building energy model and we perform an accurate simulation. So we extract the data calculated by the building energy model, and we compare it with the monitor data. Of course, if we have a mismatch between this type of data in terms of temporal discretization, we need to make them compatible in order to be able to compare them. Then we can evaluate these two data, we can compare them using both statistical indicators, such as the mean bias error and the coefficient of variation of the root mean square error, and with a graphical analysis using the energy signature. Then we can check if the results we got are actually complying with the limits we defined. In case we already are complying with the limits, the model as was created is already a calibrated model, even if we don't need to perform an actual calibration, meaning that this model is actually able to reproduce the actual behavior of the building. In case it's not compliant, we need to keep on with the other steps. But let's just focus a bit on these items we're going to use, so the statistical indices and the energy signature, just a small derail from this path. So the statistical indices that we're going to use are the mean bias error, which is an indicator that represents the overall bias in a regression of a model. On the right of this slide, we can see some of the limits that are proposed by ASHRAE regarding this value for a calibration procedure. The second statistical index is the coefficient of variation of the root mean square error, which instead indicates how much variation or randomness there is between the data and the model. And again, on the right, we have some limit proposed by ASHRAE. The third item we're going to use is the energy signature, which actually correlates the energy performance of a building with one or more parameters. In our case, we're going to correlate the daily energy need for heating with the average outdoor air temperature. But of course, instead of that, we can also use the heating degree days or other indicators in order to define a correlation between parameters and energy consumption. So let's go back to our path of calibration. We defined, as we said in the 6th and 7th step, the model, we compared the results, and we found that our model is not calibrated. So we need to keep on calibrating. So how can we perform an actual calibration? At first, we need to define which parameters are actually creating errors between the model and the actual consumption. But how can we define which parameters should be modified? We can use the energy signature in order to do that. So we can represent on the same graph the simulated energy need and the actual energy need in order to compare them. As we can see, we have some differences between these two curves. The first difference that we can notice is a difference in the slope. This is mainly related to parameters that are influenced by difference between indoor and outdoor temperature. So the parameters between A and D. The second difference we can notice is a difference in the shift. So this one is instead related to parameters not influenced by the difference between indoor and outdoor temperature, so parameters between E and G. So what we're going to do is analyze these two curves, analyze the difference in the slope and the shift, and then select which type of parameter we should modify, also based on the accuracy we know this parameter have. After we did that, we can modify these parameters one at a time or more at once. We can perform again the simulation using again the statistical indexes. We can check if the results we got are actually compliant with our limits in order to define if the model is calibrated or not. At the end, we may need to reproduce, to do this procedure several times in an iteration procedure. So we will repeat the points between 8 and 11 until we can reach the calibration. The last step, the last group of phases, is the evaluation phases. So once we have a calibrated model, we can also assess the quality of this model by creating a scale. In this case, we defined a scale between 5 and 15% for the mean bias error in order to define if this model is high calibrated, is calibrated with an acceptable level, or it's not calibrated. Okay, I think that's it for my presentation. Thank you all for the attention. And if you have any type of question, feel free to write to my email. Thank you.
Franz, thank you very much for your presentation. In case that any of our participants have any questions, you can put it in the chat or send an email directly to our presenters, whatever you feel more comfortable. Franz, once again, thank you very much. We will continue with our program. Susan is here with us. Welcome, Susan. Susan is owner and director of the Serra Institute and an environmental engineer with a background in law and trained energy advisor entitled to issue energy performance certificates. With years of experience, she has been actively involved in activities related to the implementation and further development of the EPC-related concept. She holds a PhD degree in sustainable construction from the University of Natural Resources and Life Science in Vienna, showcasing her expertise in the field of sustainable construction and energy performance assessment. Susan's work focuses on promoting energy efficiency and sustainability in the built environment, with a particular emphasis on the EPC-related practices and concepts. Susan, once again, welcome. The floor is yours.
Thank you very much, Ilya. I will share my screen.
Great.
So,
we can see your screen.
But not my presentation, I
not
guess.
Your presentation.
But now?
Now it's perfect. Just put it on the slideshow, like that.
Yes, it's like that, right?
Yeah, Susan,
Okay.
Thank you very much. Please continue.
Okay. So, all what you heard before is somehow connected to the renovation passport and delivers some input, let's put it like that. But what I would like to focus on today is how the renovation passport can enable innovative energy services. So I will take a little bit of a higher level perspective and not go into technical details. So the focus is on how the renovation passport can enable innovative energy services. In this context, the innovative energy service is the ESCO concept for building renovation. So ESCO is the abbreviation for Energy Service Company. That's an approach where the company provides the technical work, including financing. So I will not go into detail about the renovation passport as such, as this was explained in the webinar 2, that was the session 5 on March 5th. So for the details, I would like to refer you to that webinar, which was recorded, and the presentation is also available on the TIMEPAC Academy website. So a short introduction on the ESCO services for building renovation. What is the concept and what is the status? So the concept is not new at all. It means that the investment in the renovation of the building will be paid back by the cost savings due to the reduction in energy costs and other income. The challenge we have that we need a certain level of energy expenditure and cost savings, because otherwise the transaction costs will be too high for the investment to pay back. So the investment will be not economically viable and therefore not take place. So ESCO services typically address the technical building systems and large non-residential buildings, exactly for that reason of economic viability. So usually there is no improvement of the building envelope, and usually residential buildings are not addressed. The fact that residential buildings make up the largest share of the building stock, of course, that has led to many attempts to extend the ESCO concept to the building envelope and to residential buildings. So to use that concept to let's say initiate deep renovations and also in the residential building sector. But actually, these attempts were not successful so far. To date, there was only one, or has been only one widely successful approach at European level. That's the Energiesprong initiative that comes from the Netherlands. However, it's only possible provided the national legal framework permits this, so it's not possible everywhere as intended. So that's the situation we have. So the question is how to reduce the transaction cost of renovation projects, how to increase the economic viability. So in this regard, there are several tools available. These tools can display energy-related building data on a map and thus provide companies with valuable information to develop services. The display of such data on a map can assist project developers in narrowing down the areas for detailed investigation and preparation of renovation projects on a larger scale. So it can be like the first step to identify an area that could be promising to develop renovation projects on a larger scale, including residential buildings. So what you see here is a map that was produced in the ENERFund project some time ago, where EPC data were let's say where EPC data were processed and transformed to be shown on a geographical information system. So many tries that happened already. However, they were not successful for certain reasons. The benefit could not be fully realized due to various reasons. And the reasons are the following ones. So the main problem that ESCOs face with EPC data is that it is not clear if the publicized information about the building relates to the actual status. So we faced these issues that the EPC typically has a validity of 10 years. So the recommendations are often generic and the implementations are not, the implementation of renovation measures is not tracked. So actually we don't know what the actual status of the building is. It is based on standard user behavior. So we don't have information about the actual building use. The EPCs for existing buildings may be simplified and contain errors, and the EPC coverage of the building stock is not complete. So usually it's 30%, sometimes 50%, depending on the status in the member states. So these are the challenges why, or these are the reasons why energy service companies say, yes, these maps are nice and the information displayed is interesting, but for us to develop business cases, it's not sufficient. So, and this is where the renovation passport now comes in. So the renovation passport, as it is envisaged in the upcoming EPBD recast, complements the EPC and addresses many of these challenges identified. So I would just like to highlight one of the challenges, which is that these companies need actual information about the building status. So it is essential that we know if renovation measures have been actually implemented or not. So just the recommendations are not enough, just the plan is not enough. We need to know if the implementation has actually taken place. So we need the tracking of the implementation of renovation measures. And here we identified several approaches in the TIMEPAC project. We did a lot of case studies and applied different type of tools. And the conclusion, I would just present you the conclusion here. So we identified 3 approaches how to track the implementation of renovation measures. The first is we can do it through energy audit reports. These energy audit reports also contain recommendations how to improve the building energy performance. And that report could be further developed to form a renovation roadmap. However, as the prerequisite for tracking the implementation of measures, an energy management system must be in place. And this is usually the case for large non-residential buildings. So we have a useful tool, but probably only for part of the building stock. The EPC database is another approach. Here we have the prerequisite that the EPC identifier is the building and not the building auditor or the EPC issuer. That means that the EPC database must facilitate the versioning of EPCs and renovation passports over time. So in theory, it's possible for all building types because all EPC must be uploaded to the EPC database, but the EPC database must fulfill some, let's say, requirements or be capable to do this. And then we have the BIM offering software, which is one of the main topics of the TIMEPAC project. Here, as the prerequisite, we need a digital twin of the building, where we can then log the renovation measures. This is all possible for all building types with the question mark, because at the moment, it's quite an effort to establish such a digital twin for an existing building. But I think we are still, let's say this is still up for discussion, let's put it like that. But we should also consider new developments such as the digital building permit, the digitalization of the sector as such. So I think here are interesting opportunities and also future options to be discussed and also to be further developed. So here is an example how this tracking of implementing renovation measures can look like, or how is it implemented in the province of Salzburg. Actually, we have an EPC where the recommendations are replaced by the renovation roadmap. This is uploaded to the database. Then, when a specific renovation specific package of renovation measures is planned to be implemented, the EPC is uploaded again as an EPC with the planned measures. When the measures are implemented, the EPC is updated again, the renovation roadmap is updated again, and from the difference you can then see, okay, which measures are implemented. So you compare the indicators in the EPC before and after renovation and the renovation roadmap, so the measures in the renovation roadmap before and after renovation. So this is what gives you a clear picture what has been actually done and how the building performance has been improved. So to conclude, the upcoming EPBD recast gives some, let's say, requirements how a renovation passport scheme should be set up. The key, let's say, aspects are that there is the connection with the EPC, that a digital tool is needed. They should be uploaded to the national EPC database, and if possible, the renovation passport should be stored in a digital building logbook. So in terms of tracking the implementation of renovation measures, the scheme should be set up in a way that this is possible. The question regarding EPC database is it already possible? Is further development needed? Or is a new approach needed? And if a new approach is needed, then the BIM-based approach comes in, which would provide a one-stop solution to some or many of the requirements. So I will stop here for my presentation. I would just like to say that the setting up of that renovation passport scheme is not only essential for increasing the renovation rate, it is also essential with regard to the national building renovation plan. And this is just a teaser for the next presentation on the renovation passport, which will be in the 5th webinar, where I will go a little bit more into detail with regard to the national building renovation plan. Thank you very much. That was it from my part.
Suzanne, thank you very much. It was a very interesting presentation. We are right on the schedule, so I thank all presenters so far to be on time and to leave us some time to discuss all these issues that we are going to tackle here on this webinar. Number 3, analysis and visualization of EPC data and development of innovative energy services. It's my honor to present our next presenter. She is Josefina Petri. She graduated from the Frederick University as a civil engineering. Currently, she's doing her master's in environmental management and protection at the Open University of Cyprus, majoring in energy and pollution. Josefina is also a member of the Cyprus Scientific and Technical Chamber in the field of civil engineering. She began her professional career as an assistant engineer at the Water Board of Nicosia, and then worked as a civil engineer for 4 years in the construction sector, where, among others, she undertook site supervision, the preparation of bills of quantities, quality controls, communication with partners, and project coordination. As I see it, it's like she has a large experience in field. So she was employed by the Cyprus Energy in April 2023, and since then she's a part of the Department of Energy Efficiency and Renewable Energy Sources. So, Josefina, nice to have you here. The floor is yours.
Thank you.
And welcome once again.
Just a moment to make my screen share. Perfect. Can you see my screen?
Yeah, it looks good.
Okay. Hello, everyone. Thank you, Leah, for your words. Today, I'm going to tell you about identification of cost-optimal investment and creation of renovation goals. And first of all, I would like to emphasize how much time we spend in buildings, whether it is our job or our home, and this time is 80 to 90% of our entire life. And based of that, we have this percentage with 40% of energy of consumed buildings, 36% of greenhouse gas emissions is due to buildings, 50% of raw materials consumed in buildings, 40% of waste is due to buildings. Also today, we're gonna talk about building stock of Cyprus, about energy upgrades, and what government promote some energy studies that Cyprus Energy Agency work with it. Let's start with, just a moment, I have a problem with my presentation. Perfect. Let's start with Cyprus building stock. The characteristics of an area's building stock are directly linked to parameters such as local climate, culture, available construction material, existing legal framework, minimum requirements for energy performance of building, and know-how and skills of the human resource involved in the construction sector. Naturally, over the past 100 years, the building stock has changed, evolved, adapted to a range of measures, trends, and necessity of an each area. Transition from traditional construction with mainly natural materials to reinforced concrete and buildings. In recent past, minimum energy efficiency requires to have been adopted. The building of Cyprus are characteristic by great diversity. Perfect. Let's start with the buildings. Now is the graph we can see the year of construction of the building, and as we can see, a last percentage of the building were built before 2007, which translate to outdated solar system for hot water, single glazed windows. Most of them we do not have roof insulation, and if they do, it's usually damaged. Methods for heating is boiler for central heating, traditional fireplaces, gas heaters, oil heaters, and electric heaters. Also, in this graph, we can see percentages of energy consumption of the buildings, and through them, some targets arise, like energy saving targets bigger than 30%, energy class B+, commercial and public buildings, energy class A in residential buildings. Improved measures in performance, thermal insulation of the building envelope, highly efficient external windows and doors, external shading, smart meters, thermoplasters, heating and air conditioning systems, and high efficiency energy stove. And now, what is the government promoting? Government promoting photovoltaic system, roof thermal insulation, and one of the grant scheme is the saving and upgrade of residential building, who has 3 categories and the corresponding ground amount of the category. Now, let's go to one of our case study. I will show you the PEDIA project. The PEDIA project is an innovation project exclusive to a school of Cyprus, a project of a total building upgrade for quality education, a project for sustainability and the school environment. Energy renovation of 25 schools across Cyprus in order to reach the NZEP level. Now, the suggested energy upgrade measure transformed school building into NZEP. Thermal insulation of the building envelope, thermal insulation and waterproofing of flat roofs, thermal insulation inside of false ceilings, replacement of existing lighting with a new lighting, replacement of existing ventilators, repair and maintenance of existing shading elements, green roofs, and planting of trees. Here is one of the schools that we make energy upgrade. It's in Nicosia, this school. Here is another kindergarten. And now, let's see a NZEP scenario. they don't make an economic sense. But quality goals and other goals were the scope and need. When the scope of energy upgrade is not just economic viability, but also is complicated with the legislation, achieve the thermal comfort, environmental aspect, indoor air quality, pilot optimistic contrasting procedures, and increasing repeatability, smart readiness, and others. And nearly zero energy building as determined by legislation in Cyprus is a building that has a total energy consumption of 100 kilowatt square meter per year or lower, while this energy demand is covered by at least 25% by RES. This is an energy performance certificate of the building. Is the kindergarten that I showed you before. The class before was C, and now after the energy upgrade was B+. We see the 5 first schools that we make energy upgrades. We see energy savings here, energy savings in commission CO2 in emissions, energy class before and energy class after. The result is solve the critical problems address challenge with the new intervention design partners for every energy upgrades, develop of the long-term strategy of the Ministry of Education by adopting holistic approaches have been documented through the technical assistance and experience from the pilot application and promotion of the public school as a model example of a good practice in Cyprus and Europe. This is another case study, is the Element project who works in 25 houses in Cyprus, and here we have the results. You see the class before and you see the class after. And now I want to show you a small video. It's one school from Bedia, and you see the energy upgrade. Thank you so much for your attention.
Josefina, thank you very much. I have two questions related to your presentation.
Yeah.
I couldn't help notice that one of the engineer looked a little bit like you. Was this project that you were involved in, or it's just my bad
We are
monitor?
involved. Yes, we are involved.
And you were on the site as an engineer, I think.
Yes,
Yeah,
of course.
okay. Can you tell us, because this is the project that you just shown on the video, included all measures presumed in probably in energy audit or
Yes.
and are the results, did you have a chance to see the results, the real savings, the real comfort? What do you have any feedback from the site?
Yes, just a moment to share again my presentation. You can see my screen there.
Yes, we can see it.
Okay, just a moment. Okay, here is some result. We have the year of the build, the size of the schools.
Okay,
which one
of these were presented on the video?
The third primary school of Italy. This
Okay.
one. Yeah.
So did you get the chance to see, to validate the results, and are the planned savings fulfill the expectations from the energy audit and measures implemented?
That we expect, we want to make them build nearly zero energy.
Okay.
Building. And in original energy class, the class after the energy upgrade was the class D, and after the energy upgrade, the energy goes to A.
Great. Yeah. Did you have a chance to talk to the users? Are they satisfied with the comfort? In Croatia, we usually had one little problem regarding this high quality and refurbishments till let's say energy class A or nearly zero. In some cases, we had problem with comfort regarding ventilation and air quality. Did you get anything like this, or it works perfectly in your case?
It works, and maybe we are lucky, but it works perfectly now in our case.
Okay. Thank you very much, Josefina.
Thank you so much.
In case you have questions for Josefina, you have email in the presentation, and you can also send a question to the chat.
Of course. Thank you.
Josefina, thank you very much. Next presenter will be me, and it's always hard to present myself, so I will be just briefly sharing some insights. My name is Ilja Dremac. I work in Energy Institute Hrvoje Požar for 11 years. My background is as a mechanical engineering, and I start working on energy efficiency since 2008, when in Croatia we started the program to develop and to help refurbishment of the building sector in general. I have been working in this sector for many years. I did more than 100 energy audits from the buildings, industry, public buildings, private buildings. So nowadays I'm working also as an expert in the field of climate changes and doing some adaptation and mitigation measures with different scale of plans for municipalities. And I will now share my screen and present my presentation. I hope you can see it. Can you see my presentation?
Yes, but could you put presentation mode?
I'm trying, but a minute. Okay, I will put it like this. Just a second. Usually it works with F5. Okay.
Yes, it's
Is it okay?
Yes.
So in next 10 minutes, I will talk about how to make an EPC a dynamic tool for verification of energy savings. Key questions that will be addressed in these presentations are: what are the differences between real energy consumption and calculated EPC energy consumptions? What are the methods to calibrate EPC model with real consumption, and how to calculate energy savings from the calibrated EPC model? The key message of this presentation is that all energy savings and energy efficiency measures are calculated according to the actual consumption of the targeted energy consumers. So one thing it's very critical is that you make sure that calculated energy for heating, cooling, air conditioning, lighting, and other specific energy consumptions that are the topic of energy efficiency measures in EPC are corresponding measured or modeled energy consumption according to the real consumption validated with the bills. So make sure that the analysis of the real consumptions is validated with bills.
Ilya, you are muted.
Sorry. In this slide, you will see just one piece of the EPC that is valid in Croatia. And I also indicated one of the most important things for energy efficiency measures is this EDEL, which is specific annual final energy consumption in the building. This calculated value should correspond to the real specific annual energy consumptions related to the bills. If you see in the formula below, in this case, we are going to tackle just these four elements: heating, domestic hot water, cooling, and lighting. The majority of all measures that are planned and implemented in the end are connected to these specific systems. So I will try to just a second to show you what are the differences between actual energy consumption and calculated in the EPC. This delivered energy is the annual required amount of energy that is supplied to the technical system of the building for heating, domestic hot water preparation, cooling. In case that you have ventilation or climatization, it also includes ventilation and climatization, and of course, lighting. It needs to be calculated for reference climate data and prescribed standard conditions for the use of the building space. It is calculated so that necessary energy for heating, cooling, and preparation of domestic hot water is multiplied with corresponding consumption factor of the supplied energy. So we will start with the heating and cooling, where on my experience, the most discrepancies between calculated and real energy consumptions first starts with calculation of demand for heating and cooling energy. It is connected to insufficient or incorrect envelope data, because envelope defines what amount of energy do we need for cooling and heating. When you are performing energy audit, it is, I wouldn't say hard but it's difficult if you don't have a good technical documentation to see what are the real layers of the wall. So inspection on site is very important, and in this first step, you need to be very, let's say, pragmatic, but also precise. Ventilation losses, internal heat gains, and very often differences between projected and real temperature in the building. For heating, our projected temperatures is 20 degrees, but usually in the building you don't have 20. We have 21 to 25. It depends of the usage of the building and people that are have different kind of sense of comfort. For some people, the warm is 21, and for some it's cold for 22. So it will be great if you have a possibility to measure the real temperature during the heating season. The same thing applies for the cooling, where we have the projected temperature of 26, and usually in real usage of the building we have a little bit lower temperature. For calculating heating and cooling energy, you need to have good information about working schedule, working days, so that you have the calculation as precise as it can be. The other thing is the corresponding consumption factor for the heating and cooling. In this case, you need to know what kind of systems do you have installed, and make sure that you have a really correct data on the installed heating and cooling equipment. What you need to take into account are three, let's say, major points. One of them is the source. Second is the transport of the energy, and transmission in the area where the heating is on. Let's say the source can be a boiler, it could be a heat pump, it can be chiller or anything that produces thermal energy. For the transport of the energy, you need, of course, the pipes, ventilation ducts, pumps, etc. And it is crucial that the real data correspond the one that you are entering in the program. And of course, transmission, radiator, fan coil, is it done in a different way? But all these technical data will at the end define your corresponding consumption factor. When you calculating primary energy, which is one of the keys, one of the main things in EPC in Croatia, you could be wrong in coefficient for primary energy, so make sure that you use the right one, and of course that you don't have a good input regarding real energy consumption. So what are the things that you should consider, and where this discrepancy could be at the end, are that you take into account all electric energy consumers, all natural gas consumers, LPG consumers, or other consumers that consume energy for these parts that you are going to tackle in energy efficiency measures. Modeling of energy consumption is an iterative process, and while you are doing it, make sure that you get real data gathered from interviews and on-site measurements. It would be great that you can measure, for example, temperature for heating and cooling, temperature of domestic hot water, illumination, ventilation. But in case you don't, then you need to do a really good, you have to put all necessary data in the process, in the program, and do this iterative process in which you will calibrate the real consumption data to the data that you calculated. All these steps are very important because for any energy efficiency measures, when you want to implement, you need to have the good data, because if you don't get the real data that is connected to the measure, then economic validation, environmental validation at the end will be not perfect, not to say another word. So energy savings relating to the energy efficiency measures are calculated as a difference between actual consumption before the measures implementation, which is ex ante, let's say, process, and the projected consumption after the measure implementation. What the project consumption takes into account is the same operating schedule as existing equipment or system that is the subject of the measure, and the technical data, which includes efficiency of new equipment or system that is planned for installation. For energy efficiency measures in Croatia, it is quite simple because according to the methodology for calculation and presentation of results in EPC, it is mandatory to develop energy efficiency measures according to the real consumption. That's why the modeling, the calibration of the model, it is very crucial. When you get the model right, and then you have this specific energy consumption for the system or the part of the system that you are tackling in the energy efficiency measure, then it is easy because you just change the system characteristic in the program, and you will get the results, and you will get validation of the measure in energy, kilowatt hours, in CO2 reduction, and of course the financial aspect to see how much money do you save. Is this project feasible? Is it going to be, is this investment going to be returned in 5, 10, or 20 years? So for the decision, for the decision maker, the most important thing, of course, is to see, is this presumed measure or set of measures feasible? So all these steps before, modeling, calibration, bill calculation, are very important to get the real picture of what we are going to do, and at the end, implementation of energy efficiency measures that are planned in our EPCs are the final goal of what we are trying to achieve. That's it for my side for this moment. If you have any questions, please feel free to write me on the email presented on the screen or in the chat. I will stop sharing my screen now, and we have 25 minutes. Let's go for our dear friend Boris, who is the work package leader and our let's say advisor for these webinars. Boris, warm welcome from my side from Zagreb. I hope that you have better weather there than here, because we have rain all the time. I will just shortly present Boris, and then we can go on with our presentation. So Boris Sucic is a researcher at Jožef Stefan Institute Energy Efficiency Center. He holds a PhD in electrical engineering from University of Zagreb. His main areas of expertise include energy management, environment management, support in decision-making in building, in industry, modeling and optimization of energy processes, and holistic planning in energy. As the leader of energy manager training following the international EUREM program, he has extensive experience in conducting training programs. That's why he is the leader of this work package. And he has authored numerous scientific articles published in international and domestic journals and conferences and handbooks for various seminars and training courses. He has gained practical experience by implementing several domestic and international projects as a coordinator or team member, focusing on energy efficiency. He has also conducted over 100 energy audits in industry and buildings, further showcasing his expertise in the field. So I think this intro of Boris was enough from my side. Boris will add if he has something, if I forgot something, but Boris, the floor is yours. Boris, are you here with us?
I don't see Boris anymore.
I just saw his picture a few seconds ago.
Yes, but now he's not here.
Okay. I'm sorry that the last presentation of this webinar is a little bit on hold on. I will try to connect Boris via a mobile, so please give us a few seconds to make sure that he is connected. Wait, let me see. Is he maybe in the lobby? As I can see, he just disappeared.
Yes. He's not in the lobby. He's not among attendees. So
he's writing me right now, so please bear with me. He just said that his internet died. Okay, he asked for 1 minute to see how he can connect. He will probably try to connect his PC with his mobile. So, is there any questions for?
Yes, you have one question in chat from Vincenzo.
Okay,
Chat
let me
suggestions.
see.
Could you please see and comment this?
Yes, Vincenzo, you are right. Vincenzo.
Ilya, are you here?
Yes, I'm here. Let's see if Boris is going to connect soon. Let's give him a few minutes, 1 or 2, and in other case, I will open his presentation and present as much as I can his presentation. Let me just prepare it in case that we don't have Boris online. Okay, Boris.
And we have one more unsolved question for Josefina from Maria. Josefina, could you please answer this question? You have one in chat.
For some reason, I even cannot open his presentation. Access denied. That's strange. First of all, let me say I'm sorry for these technical obstacles. As you could see, I was announcing our last presenter, but in the second he disappeared, and it seems that we have a problem. I will ask him if he's.
Ilya, I'm here. I'm here.
Oh, Boris.
Yeah, I'm joining you with my connection from the mobile phone. We lost the electricity and everything. So.
Yeah, I was presuming that you are going to do that. That's why I gave you a few minutes, and I'm very happy that you did, because it would be a challenge to present your presentation from my side.
No problem at all. I'm really happy that I'm back. You will probably notice that we lost all the participants from my institute. We had some unexpected problem with the internet connection. So I will start sharing my presentation. Just give me a second.
Great. The floor is yours.
Thank you, Ilya. I hope that Ilya already introduced me. I was unable to hear everything. So
yeah, I did. You just disappeared in the moment when I was trying to say, now the floor is yours, and you disappeared.
Yeah, that's the perfect fade away. You know,
perfect fade away.
If you want to do the fade away, you are going to do it in that moment. Okay, it is my great pleasure to be here in this workshop today with you, and I'm also really happy that I can share with you all my experience related with the reporting, monitoring, and verification of energy savings. Of course, when we speak about buildings, you heard many interesting things today, but we are concentrating on measures related with energy or also with water. Those measures can be different. When we are dealing with the heating system and heat consumption, change of energy source is something typical. You know that agenda of the European Union is high penetration of renewable energy sources in buildings. So introduction of renewable energy sources in heating system is something that is typically proposed. Replacement of old boilers, introduction of heat pumps, and many other different measures that are connected with the improvement of energy efficiency in buildings. However, the real challenge is how to do the verification of savings, verification of impacts, and all other things that are connected with energy efficiency in buildings. The problem of performance gap, that is the reason why we are here. That is the reason why we decided to start with the TIMEPAC project. And here you can see, this is the example of calculated measured energy use in 135,000 of houses in Denmark. The similar situation is, according to the data I have, also in the Netherlands. We are planning to do the similar exercise also in Slovenia to see what is the situation. But you can see here that buildings, houses with the class G, actually the calculated consumption is almost doubled. It's almost doubled measured consumption, which means that those buildings, when you look at them from the perspective of the energy performance certificate, they are the worst buildings in the building stock. However, if you look at them from the perspective of the measured energy consumption, they are not so bad if we are comparing them with the classes D, E, F, and G. Also, the opposite situation appears when we look at the class A. Class A means the according to the performance certificate, the most efficient buildings, but their actual performance is almost doubled the value of calculated performance. And when you put this in the perspective of energy policy, and when we are designing the policies to tackle the energy efficiency of the worst performing houses or worst performing buildings, this means that we will not be able to reach on paper we will reach the savings, but in real life those savings will not be as expected if we compare it with the measured consumption. That all motivated us to work in a direction of trying to think what has to be done with the energy performance certificate that it can be used also for monitoring and verification of energy savings. Monitoring and verification, or measurement and verification, is the process of planning, measuring, collecting, analyzing data to verify energy savings. Why do we need it? We need it because savings cannot be directly measured, because you cannot measure the absence of something. And the key question is, can the existing EPC be used for the verification of energy savings? No. The answer is clear. That was the starting point for the TIMEPAC project. Existing EPC is a static document and cannot be used for the verification of energy savings. That all motivated us to look, to think about the future, to think about what future EPC should look like to enable verification of energy savings. And now if you can put all these three workshop TIMEPAC webinars together, then you will see the red connecting line, which is enhancing EPC in a direction of implementing and using very advanced tools for calculating EPC, putting the operational data into the story, calculating actual performance, and all those ingredients will make this soup called EPC at the end very tasteful. Overview of the measurement and verification design. There are 11 steps. The most important one is actually the how to define the baseline. How to define the baseline on which energy savings will be calculated. And from all of that you heard today, and especially during the last presentation given by Ilya, you realize that you have to compare the data, calculated data, with the actual performance, because that will help you to see in which direction of the performance gap you are moving. When you are comparing the actual when you are comparing calculated to actual performance, you are also able to see the discrepancies. You are also able to see the deficiencies, and that will also help you to create reasonable and reasonable energy efficiency measures. Baseline period, as I said, that is the trickiest part. If it is not defined well, that means that anything can happen. Every improvement process starts from the known performance level. Of course, available data must be processed to represent the baseline data set. You have learned during the webinar number 1, if some of the data is missing, how you can compensate that. And also, you are usually using the data over the last year, 2, maybe even sometimes 3. This is the trickiest part of the energy performance certification, and also auditing, and also measurement and verification. Please be aware that baseline period should be without any interruptions on unusual operating conditions. Don't forget that you have to collect also the energy relevant data and the context data. I will go back to this slide and show you ask you a simple question. Why do you think that houses labeled with G are having actual performance so much better than the calculated consumption? In the context of Slovenia, I can give you the answer. A lot of old people are living alone in relatively big houses, and they are not heating entire house. They are using a room or 2 and the kitchen. And that is the reason why the performance is not as expected by the calculated EPC. Also, that means that those households are somewhere on the border of energy poverty. This is also another tricky point of energy definition of energy policy. I will go back, try to connect the problem of metered energy consumption in the EPBD, just to provide you the context what the recast is bringing there. Recast is in its article 19 talks about the databases where the data is stored, and metered energy consumption is also mentioned there, which means that in the new enhanced EPC or the should also be somehow connected with the metered energy consumption. That is clear for me, because throughout the Europe, rollout of smart meters are going on, and this data, if it is not available now, it will be available tomorrow. Also in the Annex 1, it is stated that member states may use metered energy consumption under typical operating conditions, which means that you always have to normalize that to verify the correctness of the calculated energy use and enable comparison. This is also another very important element which will help us to define the appropriate measurement and verification plan, and also to verify energy savings. Also, many different issues are still still open, availability of data, smart meters, privacy. Those things are tackled in a different ways in different member states. Metered energy consumption, interesting insights from Slovenia. From these two on this slide, from these two pictures, you can see that in Slovenia, we actually have a lot of meter data already available. On your left side, you can see the view. It is not a proper heat map, but it is the view of heat map from the city of Ljubljana, where all the buildings that are connected to the district heating system, you can see their actual energy performance regarding the heating system. On your right side, you can see the data from the electricity power utility regarding the capacity of roofs for connecting connecting PV system. Of course, in those attendants that are coming here from Slovenia know that if we have the smart meter already installed, we can see the 15 minutes data from our meters directly. It can be obtained very easily, which means that availability of meter data for us is already here. And this can enable us to be a testing place or testing environment for the dynamic EPCs. When we go back to the monitoring, measurement and verification protocol, there are different options for measurement and verification mentioned in the protocol, but in the context of the EPC, option D, calibrated simulation, is actually the entry point for the dynamic EPC. It connects everything that you heard during today's presentations. The savings are determined through the simulation of energy consumption and the demand of the entire building. Actually, you do all the simulations that you need to do, compare the actual consumption with the calculated consumption, and based on that, you are able to define or be able to verify impacts of implemented energy efficiency measures. You are able to verify impacts of your programs that are implemented there, and also define some corrective actions that needs to be implemented. This means also that the dynamic EPC for verifying performance improvement has to include another new dynamic and the context-sensitive indicator. We call it energy performance coefficient, which is the ratio between actual to predicted energy consumption. EPC based on energy consumption. In this way, you can by using energy performance coefficient, you can identify changes in energy consumption. Can be basis also for the verification of energy savings. As my conclusion, I can tell you that from my personal experience, I have done many energy audits in Slovenia and in Croatian buildings and industry. Dynamic EPC has a potential to serve as a tool for the verification of energy savings. It is especially when you use the advanced tools for modeling energy consumption in buildings. Be aware that actual energy consumption must be included, but transparent definition of the baseline consumption, it's the key element. Properly calibrated EPC is the most important step. Combining activities, you have learned through the webinar number 1 that if we want to be cost effective, we must combine activities. Energy performance certification, auditing, inspections, modeling, energy management, all those activities should be combined when we are dealing, of course, with the complex buildings in order to provide cost-effective documents, cost-effective measures, cost-effective advices to the building owner, energy managers, and facility managers. Of course, presentation of benefits and limitation of all approaches should be compared with the possible alternatives. Don't forget that our final goal is implementation of advanced projects. Thank you very much for your attention. I'm really happy that I was able to join you. We showed you in the practice that we are able also to cope with different situations and different problems, like losing the power supply and connecting to the webinar through the mobile data. Thank you very much. And if there is any question in the chat, I'll be happy to answer on it.
Boris, thank you very much for your presentation and for your availability to participate. No matter what kind of problem that you have in your institute regarding energy and electricity availability. I think we can conclude our webinar for now. I would like to say thank you to all participants. In case, Boris, since you are the host of this work package, if you have anything additional to say to our participants, please do. In case not.
Thank you, Ilya. I will use this opportunity also to invite all our participants to join us on Thursday, when we will deal with when we will have our fourth webinar. That fourth webinar will be organized and will be the fourth webinar will be dealing with combining EPC databases with other sources for the holistic assessment of the building stock. It will be organized by our dear colleagues from Spain, La Salle group. So we will be happy to see you all on Thursday too. Thank you, Ilya, and thank you all.
Boris, thank you very much. If this is it, I would like to thank all presenters at first, and then all participants for joining us. Join us again on Thursday. You will get the link for the next webinar. And that's it from Zagreb. Thank you very much.
Thank you, Ilya. Thank you all.
Just a second. You have one question.
Yes, any question?
Ružice, please. I was so busy thinking what I'm going to tell for the farewell, but go ahead and tell us if we missed something in the chat. Do we have any questions?
Yes, we have questions about presentations. When we will have the presentation uploaded?
All presentations are already on our site, but I don't know on the
guys' presentations will be available in the next hour on the TIMEPAC Academy. Everything will be available there. Please don't forget to use or to evaluate us and answer to our survey. Ilya, please share the link for the survey in the chat, and also, guys.
Alvaro, I think already did, but if case he didn't, I will gladly share the link for.
And you will also receive, all the participants will receive an email with a thank you note and the link to the survey. That will be it.
Great. Ružice, do we have any other questions?
No, that's it. Thank you.
Okay, congratulate to everybody. It's sharp noon, so we are right on the schedule.